So because the hydrogen peroxide can go both ways. It's a schwinger. Okay. So we're gonna go through these and just to kind of as a quick review. And if you want to scooch up some. But so I'm videoing right now too to help with prediction. But right now this is just like old school prediction. You have to know some of the general rules, right? Well, you have this nice cheat sheet right in front of you. And generally, they haven't had a lot of redox prediction on the AP exam. They've had a lot of redox balancing, like balancing acids and balancing bases with your half reactions, but they've already predicted the products for you. Or they'll give you hints like, oh, it's blue, or it forms a gas. It'll give you prediction help clues, okay? So as you're going through these, kind of just start to think about the relationships between them, and then I hope it'll help you a little bit as you're continuing to go. So, potassium nitrite, potassium dichromate, what's one of the products we know it's going to produce? Levi. Okay, so you're saying the nitrate, the nitrite forms, this is predicted to form nitrate. So I'm writing this in half reactions. That's a 1 minus. I'm writing this in half reactions because you can see it's in base, right? So it's going to be balanced in base. So we're going to have to kind of deal with that. Okay, so the potassium and the potassium are both spectator ions generally. Go ahead, what's the next? What's the dichromate going to automatically form? Vicky. 3+ charge, right? Okay, so any of that thing that's dichromate or chromate is always going to form chromium 3+. This is a very common half reaction or reaction. So always just remember that chromiums and chromiums are, dichromates and chromates are going to form chromiums. Okay, so which one you guys want to do first? Top one? Go for it. Shout it out. What's next? Add. Thank you, Avery. Add water to the reactant. So then we have oxygen, oxygens, 3 oxygens. These H pluses now need to be handled, right? Okay, so what do I do here? Add 2 H to it, or H pluses. Okay. Oops. That's supposed to be 2 H pluses. And then what? Say again? So balance the charge with electrons. So what's the charge, net charge on the reactants? 1 minus net charge on the products. So 1+, right? So 1+ from the 2+ and a 1 minus together. So what do I add my electrons? Reactants or products? Products. How many? 2 electrons. Because I have now 2 electrons, which brings me down to a 1 minus charge overall. So the charge has been balanced, right? So here's what I'm going to do. I'm actually going to implement the OHs here because on the next step, it's going to get kind of messy altogether. We did it last time with all the OHs at the bottom, but we can actually do it earlier, and that's fine. So right here, if I know that I'm balancing in base, I have to go ahead and account for that. And what do I do with that? Who cannot exist freely? H pluses, right? So if I add so many hydroxides to one side, I have to do it to the other side. Why? My charge has already been balanced, right? So to keep that charge balanced, I have to implement the same exact thing on both left and right. So I have 2 H pluses here, correct? So I'm going to add 2 OH minuses on this side and 2 OH minuses on this side. Now, I'm going to keep all this for now, but I know that these will come together to form what? Water. So right now I'm just going to kind of circle those and know that those are going to be 2 waters for me at the end. So I'm just showing another method of this. Do whichever way makes most sense to you, but know that you can do that now or do it later. It's going to come out with the same result. It's just going to be more simplification needed. Okay? So chromium, we need 2 for the chromium because we have 2 chromiums. What's next? 7 waters on the product side. So that gives us 7 oxygens and then 14 H pluses, right? It's kind of becomes redundant because you've probably written this reaction like 3 times now. And then 14 H pluses. What's my net charge? 12 plus and 6, right? 2 times 3 is 6 plus. So 12 plus on the left, so 6 plus on the right. What do I add? 6 electrons on the reactant side. Okay? Knowing that we have to have charge balance for the electrons, we'll get there shortly, but right now I have H pluses that need to be dealt with. So I'm going to do the same situation where I added my hydroxides, so add your 14 hydroxides here. Those are going to come together to make 14 waters. And because our charge balance still exists, we need to keep that charge balance. There's, oh, sorry, not 6, 14 OHs. Just making sure you're flexible and can balance in two ways. So these 14 OHs and 14 H pluses will form 14 waters as I go. Okay, so in this case, are my electrons balanced from redox, oxidation and reduction? Are they? 2 and 6. So I need to multiply the entire top reaction by 3, right? This is where it gets messy. So the entire top reaction comes by 3. This whole shebang. All right, so I'm going to simplify, or I'm going to write down on the bottom and kind of bring it together as we go. So 3 times 2 OHs, 6 OHs. And then 3 waters plus 3 nitrites yields, plus all this junk on the bottom, okay? 6 electrons and 6 electrons we know are going to cancel automatically, so I'm actually not going to write down right now. So that's 14 waters still, because the H plus and OH comes together to make water, plus dichromate. Let's get long, guys. There's all my reactants. Yields 3 nitrates, plus 2 waters, right? 2 H pluses and 2 OH minuses. 2 waters, plus, I'm sorry, not 2, 6. Not bad. 3 times 2 is 6. 2 chromium 3 pluses, plus 7 waters, plus 14 OHs. Is that right? Yeah, I think I caught everything here. Okay, so if you're a fan of simplifying up top, that's totally fine as long as you're not, as long as you're doing it correctly or simplifying down low. So what would I simplify down here? Okay, so I got 14 OHs on the product side. I have 6 on that side, so these are now obsolete, right? So 6 OHs are totally gone. So when I do a full X, that's me canceling them out entirely. And then how many OHs are left over here? 8, right? So 6 and 14, that means 8 are left over here. 8 OHs on the product side. I have net 17 waters, right, on the reactant side, and 13 waters here. So these 13 waters are gone. Because 6 and 7 versus 17, so how many are left over here? 4. Okay, so I have 4 waters left. Here we go. I think we're done though. So overall, my full reaction, I'm not going to rewrite this, but I'm going to say it out loud, would be 3 nitrates plus 4 waters plus a dichromate yield 3 nitrates, 2 chromium 3 pluses and 8 OH minuses. That's balanced and base. Whew. All right, so for the next couple, I'm just going to show you the predictions that should have occurred because I think you're okay with balancing an acid and base. Am I assuming too much or is that okay? Okay, thank you for shaking your heads. All right, so our next one, we have acid. So we have the peroxide, which is interesting because it forms 2 products. If peroxide was to decompose, let me recap that real quickly. If just peroxide was decomposing, what would be the 2 products it would form? Water and oxygen, correct. Okay, so this is where we actually have peroxide forming a product that's through oxidation and a product through reduction. So if I have peroxide and I have to label its oxidation states, this is a side note, by the way, make sure you're watching that because this is a pretty common one. What does peroxide's oxygen have here as an oxidation state? Kirk, you with me? Okay, if you don't know oxygen, go with hydrogen. This is a +1, so what does this oxygen have to have? A -1. This is the peroxide that has a -1 oxidation state. Oxygen itself, oxide, has a -2 oxidation state, but peroxide has a -1 oxidation state. So it actually is both oxidized and reduced. This is a disproportionate redox reaction. Oxygen here goes to the O here, which has an oxidation state of what? -2. What's happening here? So it's getting electrons, so it's reduced, right? Okay, so just making sure you can at least identify the one that's reduced versus the one that's oxidized. This oxygen, I'm going to a free element is a 0, so then we have a -1 and 0, so what's that? So it's losing electrons, so it's oxidizing. Okay, so if you can do this by a decomposition, you can easily figure out which is the product that's going to be produced from this particular reaction number 5. So Ki, let's start with Ki. What's happening with Ki? Who's actually being predicted to form something? Yes, the iodine is doing what? It's going to its diatomic form. I'm going to rewrite this down here because I'm out of space here. So H2O2 plus Ki. So you're saying I1 minus goes to I2. Is that being oxidized or reduced? I1 minus, which is iodide, going to I with a free element oxidation state of 0. So that's being oxidized, right? So if you have to think, and you don't have your cheat sheet in front of you, which of the peroxides is going to happen? Forming of water or forming of oxygen? Water, because it has to be the reduced version, correct? So that's how you can, if you know this, and if you had to figure out, you know, I have something oxidized already, I have to find something that's reduced, you have to form the reduced version, which is water. Does that make sense? Okay, cool. So we got water. And then you guys could do the balancing. I don't think there's anything tricky there. No, not really. You might have to balance. So the only thing that's kind of tricky is if you have peroxide, H2O2, and you're forming its predicted product of water, and you're trying to do your half reaction, and you're balancing an acid, what's the very first thing you're going to do here? So you have to balance all your non-O's and H's. Okay, that's balanced. So then what would you have to balance next? The oxygens. So what are you going to add to this? Another water, right? So then I would just be putting a 2 in front of that. Say I now have 2 waters. That's just a kind of crazy, because you're like, I already have water, let me add another one. It's just there for balancing purposes. And then you would combine those to be 2. And then everything else kind of makes sense. All right, on number 6, which is magnesium plus HCl. What kind of reaction is that? That's actually just a straight up single replacement reaction, and you can do that one in your head by inspection, by normal balancing, and then also you could do it by half reaction, so they both work out. So what would that be forming? Just straight up, do a single replacement. MgCl2, because you have to crisscross your charges, and hydrogen gas. Hydrogen gas is diatomic, do not write it by itself, right? It's diatomic. Okay. So we're starting to blend redox with other types of reactions, basically today. And so you guys have 13 reactions. What I want from you is an easy way to allow us to read each other's reactions, because versus you guys doing all 13, you're going to be sharing some of these, and you're going to do it in a simple way. So I have I'm going to tell you guys are doing 1 through 10, and I'll just tell you this now in case you finish your lab early. Find this on your packet. It says, practice with NIEs and predicting products with redox. There are 10 reactions there, and each of the reactions has a sub-question that goes along with it, kind of like last unit when we had that sub-question that went along with it. Give me a thumbs up when you find it, put a star next to that. Okay, so just circle that. If you finish your lab early and we're waiting on the other people, I don't want to waste time, I don't want to waste your time, so I want to make sure that you have this so that you can jump on that soon. Alright, so 1 through 10, that was a side note. Ready? So whenever you get in your new groups, what you're going to be doing is you're doing your 5 reactions that you've selected or I've selected for you, and you're going to just write out something, and it can be on notebook paper, it can be on colorful paper, and I have like index cards, or you can do something more creative, but basically the reactants are given, everyone can see the reactants, so that's no secret. But then your products that you're predicting to form, your products are going to go under here, and you can put an index card right there, and you can flip it up, or you can make some sort of way to hide that. So like if Levi's doing number 13 and Courtney's going, okay, let me check myself, can I go ahead and do this? She's going to look there, she's going to flip it up and say, okay, I predict the products correctly, and then the correctly, balanced throughout, if it's balanced in acid or balanced in base, will be underneath. And of course you can hide that as well. Your observations that you saw should be there, and they should support the products that were formed, right? So if you predicted you formed a gas, and you didn't see a gas, you're probably wrong, correct? And I will try to help you along with that as you go. But I'm probably the third line of defense here. So most of these reactions are redundant, meaning more than one group's doing it, which you guys can see here. So basically what I would do is I would say, okay, Courtney's group and Levi's group are both doing number 6. Let's make sure we have some common predicted products and we balance this the same way. Okay? So what we're going to do is we're going to kind of, if you want to videotape your, or take a picture of your results, some of them are really cool and interesting. Some of them are less cool and interesting. There's one that makes a flamethrower. So I'll make sure I'm with that group when we get back there. But other than that, we're going to finish this up today. And when we display our reactions, your job is to make sure you get that reaction in your notebook. or on your paper. Right now you have paper. You're gonna be taping them in your notebooks. I have not gone close to done with notebooks today, so you guys are gonna make sure that you have that neat enough that you can tape that into your lab notebook so that you're not having to copy everything over again. So that doesn't respect your time. Okay, so if you want some paper, I have paper over here. Let's go see where everything is in the back, and let's go. You guys know what you're doing. Do you feel okay with this? You're not doing all 13? In a second. Yeah, let me get people started first, okay? So make sure you have shoes and hair kind of pulled back. I have one group with the Bunsen burner. And so if you're, I think it's number 3. I think it's number 3. Hold up. I think it's number 3. Who's reaction 4? Okay.
For number 5.
Yeah.
It's like process of water.
Yeah.
Completely attached.
And you'll put